Now, here I taken a block. When I don't apply any force, basically what happens is through the center of gravity or the center of mass, the weight mg will act. And the normal reaction by the ground, okay, this particular thing is ground, will pass through the center of mass. Okay, this is a normal reaction. This will be acting. And what is the state of this? This will say at rest or equilibrium. So there's a basically a center of mass, the weight will act. Here the normal reaction by the ground on the block. By the block on the ground will act in the direction. This will be no use for us. Now let me apply a force for this. Then we'll see that what conditions will arise here. This is without any application of force. These are the forces that are acting. When you apply force, then we'll see what conditions will arise here. Okay, now I'm applying some force F on the top of the block. We'll assume some dimensions. Let H be the height of the block. Let length be the L be the length of this one. Let L be the, these are the dimensions we are assuming. So we are assuming a block of this kind of B, L, this H. So we are assuming some rectangular block whose height is height, length L, and this is a breadth B. The weight mg will act through the center of mass. As I start applying this force F, the normal reaction earlier which was acting here, now it starts shifting up. So it will start acting at on the right side of the center of mass. So here this particular thing, the normal reaction will act like this and will start shifting it. Next question comes, what makes the normal reaction to shift? So we'll start with this one. Suppose say let the normal reaction be at the initial point only. So why you are shifting normal reaction? Let the normal reaction, let it act. Let the normal reaction act here only. So we'll discuss about the torque about the center of mass only. So how the torque due to center of mass will be? This will be R bar, this F bar. The torque due to the applied force will be clockwise. Then this particular block will start rotating about the center of mass due to applied force. But we know that it is not rotating. What is the state of the block? The block is not rotating. Rest or equilibrium. But due to the a torque due to applied force, so you can see this is R bar. This net torque will be clockwise. So then what should happen to the block? The block should rotate. But as such, we know that it's not rotating. So I'll write here, block at rest and not rotating. I think there's some issue, no? So we are claiming that net torque is non-zero about center of mass and not rotating. So what actually practically happens is the normal reaction, what we assume that will pass through center of mass, in fact, will not pass through center of mass. Then where do it lie? It will shift like this. It will act somewhere here. So let this be X here. This is a normal reaction. The normal reaction starts shifting, will start moving away from the center of mass and it will act in this particular direction. Now we'll see that how the net torque about center of mass is zero. So from the net torque about center of mass, why it should be zero? Because the block is rest, no? Block is at rest. And not rotating. So for that purpose, so what is the torque by the applied force? So this will be the perpendicular distance. So how much will get this as h by 2? Let me write, indicate here. This distance will be h by 2. So now torque due to applied force will be F into H by 2. This will be clockwise. Huh? You can see here now. This R bar, this F bar. So the net torque will be clockwise by the applied force. Then torque due to the normal reaction. Torque due to the normal reaction about the center of mass. Huh? This is R bar and this is N. Huh? So the torque, this will be anti-clockwise. Then that everything we are showing in terms of perpendicular distance. What is the perpendicular distance? Perpendicular distance, this will be the perpendicular distance. And the N bar is acting like this. So this will be like a X bar. Everyone okay? You are able to understand? No. So torque due to normal reaction will be N into X anti-clockwise. So this will be F into H by 2. Clockwise, let it be take negative. Anti-clockwise, let it be positive. You can see clearly now the block. Why it will, though we applied a force F, why it will not rotate? Why it will not rotate? The reason for this is like because of the net torque about center of mass is 0. That's why what it is not rotating. Okay, so then you applied force F. You applied force F. Then why it is not moving? Okay, then we'll bring the idea of the friction. If it is kept on the, if like a rough ground usually will be rough. If there will be a friction acting. Then I say block is at rest. Some static friction will act. Then torque due to the static friction also, how it will act? It will act in the F into this distance will be H by 2. So this also will be clockwise. So here, try to see this one. The torque due to friction, this R bar, this F bar. So how the torque due to friction also, this also will be clockwise. Then how much it is equal to? It is equal to F into H by 2, this distance. This is the friction, this is the perpendicular distance from the axis, like F into H by 2. This will be torque due to friction. This torque due to applied force. This is a torque due to normal contact will be anti-clockwise. Okay, I did this. So this will be our right teacher. This torque due to friction. This is a torque due to applied force. This particular thing is torque due to normal contact. Okay, what is the basic conclusion? The normal reaction can shift. Here, the normal reaction basically till now what we analyzed is like it will act opposite to the mg, but the basically normal reaction what can shift, depending on the requirement. Why it will shift here? Because the net torque about center of mass will be 0 due to applied force and the friction. This will set up clockwise. The torque due to friction also clockwise. Torque due to normal reaction will be anti-clockwise. So for that purpose, the normal reaction will not act here. In fact, will shift. So will shift here. So it starts shifting like this. So this is one basic idea. Now we have to discuss like for what maximum value of F the block will topple, all this basic condition. So what is a very important point we are going to conclude. Note the normal reaction can shift. There's one very important thing which we'll be using in our all discussion. Can shift. The requirement is there. That's why it is able to shift here. Here, the net force, net torque is 0. Okay, the normal, the net torque about center of mass due to weight mg is 0. That's why torque due to n is also 0. So here it will not shift in this case. Here it is shifting. It's all about this shifting of normal reaction is what we'll be using in almost all the problems. Okay, fine.